Oops, all right. I started before the phone was on. The record was on. All right, let's go over SOHCAHTOA again, and then we're going to use it basically backwards to find angles instead of finding sides. So here's the thing. Sine, if you remember, is opposite over hypotenuse. And this is the angle. And these are the sides. So if we're going to undo, basically find the angle, then what we're going to do is we're going to put the sine -1, which would be, I'm going to change colors. Second sine is the buttons you're going to push to get that. And then you're going to put in parentheses the fraction opposite over hypotenuse. And then what you're going to get out is the angle degree. So we're basically undoing, because we know two sides, we want to know the angle. So cosine is adjacent over hypotenuse. So if I want to find the angle, I do second cosine adjacent over hypotenuse. I'm putting the numbers in, and that's going to give me the angle measure. Tangent is opposite over adjacent. So to find the angle measurement, I would do tan -1, second tangent, opposite over adjacent, and that would give me the angle degree. Okay, so let's try this in our calculator and see how it goes. Something to remember is if you're finding side length, you want 3 decimal places. If you're doing angle, you want a whole number. Okay, so the first thing we're going to do is we're going to practice with our calculator. So you're going to do, remember, we're going to do second sine, which is sine -1. And we're going to put 0.7230 in the calculator. So I have no idea where. I was going to use my phone. Oh, here it is. Okay. Except I have to find out where to find all this. Okay, so I'm going to put in 0.7230 equals. And the angle I get, remember I'm putting only whole numbers, is 46 degrees. All right. So for the next one, I'm doing tan -1, 5.370. So I'm going to do tan, second tan, 5.370 equals, and I get 79.45, so I'm going to leave it at 79. Okay, and then my cosine is going to be second cosine, 2, 4, 5, 6, and so I'm putting in 0.2456, and my answer is 76 degrees. So that is how you change the fraction, which is two sides in a fraction, to the angle. Okay, so let's try this with a triangle. So remember, we're still going to follow the rules. Here's my x. The 9 is the adjacent because it's next to it. The 15 is the hypotenuse because the hypotenuse is always the hypotenuse. if I have adjacent and hypotenuse, that's going to be cosine x equals 9 over 15. So I could change 9 over 15 to a decimal like we had in 1, 2, and 3, but I can also just put the fraction in my calculator. So to work backwards, I'm going to do second cosine 9 over 15 equals, and then whatever I get is my angle. So I'm going to do cosine, and then in my parentheses, I'm going to put 9 divided by 15. And then I'm going to close my parentheses. And then I'm going to hit equal. And x equals 53 degrees. So I'm still finding my angle, labeling the sides that I have information for, and then picking sine, cosine, or tangent to work backwards to find the angle. So this one looks the same because even though the angle's at the bottom, I have this information, which is still my adjacent and my hypotenuse. So it's cosine again. So I have cosine x equals 8 over 25. So I'm going to have second cosine 8 over 25 equals x, and x equals second cosine 8 divided by 25. And that equals 71 degrees. Okay. Same steps as we were doing before, except now we're using second cosine, second sine, second tangent. All right, you should be able to try these. Opposite, hypotenuse. Opposite and hypotenuse is sine x equals 1 over 20. So if I need the angle, second sine 1 over 20 equals x. X equals second sine 1 divided by 20 is 2. Oh, I'm rounding to the whole number, so I'm just going to put 3 degrees. So I'm going to put 2.9. Which makes sense because if you think about it, that hypotenuse is super long and that side is super small. So that triangle is not a really good picture, which is going to make angle x super small. So that kind of makes sense to me. All right. For this one, I have the opposite and the adjacent. Opposite and adjacent is tan. So tan x equals 6 over 5. So that means x, the angle is second tan, 6 divided by 5. And when I put that in my calculator, I get 6 divided by 5. So my angle is 50. Okay. Remember when we have word problems, there are always right triangles. So here's my right triangle. So this is my tree, and part of the tree trunk broke, and the top of the tree now is going like this. So here's like there's my tree that fell over. Okay. So this is 5 feet, and 15 feet away from the base of the trunk is going to be right there. Find the angle the broken piece makes with the tree trunk. Aha, that's going to be right there. Okay, so if I'm looking for the angle the broken piece makes with the tree trunk, I have opposite and I have adjacent. So I'm going to use tan x equals 15/5, which is 3. So if I want to know the angle, I'm going to do second tan, and I'm just going to do 3 because 15 divided by 5 is 3. So that's my x. X equals second tan 3, which would be 72 degrees. Okay, again, right triangle. Ooh, that's really long. Okay, so here's my ladder leaning against a wall. So this is 12 feet. This is the wall, which is 9 feet above the ground. Find the angle the ladder makes with the wall. Here's my angle. Adjacent. Hypotenuse. So that's going to be cosine of the angle is 9/12. Which means if I want to find the angle, second cosine, 9 divided by 12 equals x. So my angle is, what did I say? Cosine? Second cosine, 9 divided by 12. And that means x equals 41 degrees. All right. So I have a student and a shadow. So here's my student. And he is 5.667 feet tall. And then his shadow down here is 16 feet. What angle does the sun make with the ground? So here's my x. Here's my opposite. Here's my adjacent. So tan x equals 5.667 divided by 16. So to find the angle, second tan, 5.667 divided by 16 equals x. X equals second tan, 5.667 divided by 16. So that makes 19.5, which is a 20-degree angle. All right, there you have it.